So if you're in calculus and you are looking at the limits unit, one of the next topics would be calculating instantaneous velocity. So if we start off with looking at that average velocity formula, and if you have a calculus textbook, you might see the change of s over the change of t. That s is just talking about your distance. With this, it is coming from your slope. That's how we're finding that average velocity. And then it gives you some information here. Now, if we look at our first example, the ball is dropped at 450 meters above the ground. How fast is that ball falling after 3 seconds using the formula f of t equals 4.9 t squared? So here, just this note at the bottom that's written kind of small, that it's hard to find an instant velocity at that time, but we can make it so that we have a very, very brief time interval, such as 1/10 of a second. So we're going to take a look at when the time is equal to 3 exactly, and then when the time is equal, the second time would be 3.1. And we can make it even smaller and smaller, right? We could have done 1/100th of a second or even smaller than that, but this is just giving us an idea of what it should be, giving that velocity. So we know our velocity formula is going to be the change of distance over your change in time. So in this case, it's going to be your function at the time 3.1 minus the time of your function at time 3 divided by the times change. So 3.1 minus 3. So we're going to plug these values into the formula to figure out what the distance is at those times. And you would get in here, just putting it into the math, you would have 4.9 times 3.1 squared minus 4.9 times 3 squared divided by 0.1. So plugging that in, you get 29.89 meters per second. Now, is this accurate? Well, it's close, but again, we can make this time change on the bottom even smaller and smaller and smaller and see what we tend towards. If we're doing that, we are actually finding that instantaneous velocity. So it's, if we keep shortening that interval, you'll see that your velocity is actually more 29.4. So we can do this by using a limit. So if we're going to use that limit, I just want to make sure I have this here. So if we're going to use that limit, we're going to see that we're looking at the limit as h tends towards 0, right? We don't really want there to be a change here. We want it to have a very, very small, or not even a change at all. We don't want the denominator to be, because we want it to be instantaneous. So if we're plugging this all in, what we're getting, just going over this, sorry, is f of that 3 plus h. So this is now just using the limits formula over f of 3 all over h, right? So this is that first principle that we took a look at already. So we're going to plug in some of those values now using that same formula, and that's going to be 4.9 times 3 plus h squared minus 4.9 times 3 squared divided by h. Now we need to simplify all of this so we can expand it out and then factor out a 4.9. So I actually probably will take that 4.9 out first. And then if I did that, I would be left with that 9 plus 6h plus h squared minus 9. And this is all over h. We can simplify this even further because this would cancel. And we would have, looking at here, 4.9 times 6h plus h squared all over h. And we can take that even further by factoring out an h. And then we, and then we would see that one of those h's would cancel, and we would get 29.4 plus 4.9 times h. So again, we're taking one of these out and we'd be left with just one there, and then you'd also be distributing that through. Sorry, if the math was going a bit too fast here, let me know. I can always do one other video where we slow that down. Now that we have this, we can plug in that limit. So if h was 0, and we plug that in, that's why we're getting that value of 29.4 meters per second being the actual velocity at that instant time. So we're just making that time interval smaller and smaller and smaller until we know exactly what it would be tending towards. I hope you found this helpful. Stay tuned for some more videos, and if there's any other one I can do for you, let me know. If you're in Chemistry 30, check out some of my chem videos. Thanks for watching.